Hello, everyone. Welcome to our webinar on how to secure your cloud-native applications in the DevSecOps age. So hi, I am Saujanya, Product Marketing Manager at Roden Schwarz Cybersecurity. And we have with us Edward Vio, who is the Head of Product at Roden Schwarz Cybersecurity. Also, our guest speaker for today is Sandy Carrelli, who is the Principal Analyst at Forrester. We are pleased to welcome you, Sandy. So before we begin, I would like to share a few technical details. The webinar is going to be recorded and the link to access it will be available within a few hours. Also, please feel free to ask any questions that you have in the chat and we will address them towards the end of the webinar. So thank you for attending today, and let me show you a high-level agenda of what we are going to talk about today. So first, we are going to share interesting trends around development. Then we will give you a refresher on the DevSecOps age, talk about microservices security. Then we will introduce you to a cloud-native application protection solution, its underlying concept, some potential use cases, and how to integrate it in your existing Kubernetes environment to improve the overall security and scalability of your containerized applications. Then we will finally show you a demo on how to reduce false positive rate in the production phase. And then finally, a Q&A session. So let's get this webinar started. I will hand over the control to Sandy.
All right. Thank you so much, Saujanya, and good morning, good afternoon, good evening, everyone. Thank you so much for having me. You know, we're going to talk today about DevSecOps, and it's probably good to have some context on why we're talking about this. Our goal within DevSecOps is to embed security into the development and operations process, and a lot of that is about speed. You know, the importance of speed is going to be really a recurring theme throughout this webinar, and it makes sense because ultimately the goal of development is to put cool features, put new content, new product into customers' hands. That's what development teams are incented on. That's what they're paid to do. They're paid to get product to market, and they want to do that quickly. And what we're seeing is that those teams are moving faster and faster. You know, they've increased the number of developers that say that they are releasing applications monthly or even more frequently. You know, it was 27% a couple of years ago, and now it's all the way up to 41%. So that release cadence continues to increase. Our job then as security professionals is to enable that speed of development, help developers get those products into customers' hands, but help them do that in a secure way. So this is about meeting developers where they are, but helping to enable the speed that they need to do. So let's talk about some of the emerging technologies that development teams are adopting in order to meet their goals, and we'll then get into what that means for us from a security standpoint. First, APIs. APIs are fantastic for providing new ways to engage with your customers, to engage with your partners. It allows you to share data more readily. It allows you to provide new revenue opportunities, new routes to market. It allows you to build much more modular applications. A lot of organizations that I talk to mention that they are building their applications API first. And yet APIs are also a critical exposure point because if you don't protect them, you see a lot of data leaks. And I won't go through all of the examples that are listed on this slide, but there have definitely been a number of incidents where unprotected APIs that perhaps don't go through the right authorization processes or are unauthenticated, or perhaps the organization didn't even realize they were publicly available, are leaking sensitive customer information, whether it's names, spending information, contact information that you weren't expecting would be shared among the public. So APIs are one example of a technology that enables development, but also, if unprotected, can lead to risk. What are some of the others? Next slide. Low code. Low code is something that has taken off quite a bit recently because low code platforms allow more than professional developers to be developers. It allows citizen developers, those who have never had to study software engineering or development in school, to build business critical applications and get them out to market quickly. And what we found during the pandemic even is that companies that had that low code mentality, had digital process automation platforms, were able to be agile. They were able to be responsive to customer needs and get new applications out there, meet the changing customer needs in their environment. So they were able to be responsive during the COVID crisis. Again, that offers a tremendous amount of speed. It allows you to align much better to the business, but security still has a role to play there. And we'll talk about that shortly. The final area that's really helping to enable development speed is open source. Next slide. This allows teams to focus more on building the features that are differentiating for their products rather than spending time trying to reinvent the wheel. For example, open source libraries that cover issues such as encryption or storage or graphical interfaces allow organizations to make more repeatable products and then focus on specifics around the business logic of how their applications work or the particular user experience. And what we've seen is there's been a huge ramp up in open source adoption. 5 years ago, when you looked at applications, about 36% of the application was open source libraries. Nowadays, it's up to 70%. So you're seeing this tremendous increase in open source usage within the application. That means that you have to be spending some time understanding what's in your application. Make sure that there aren't vulnerabilities in all of these new open source libraries that you're adopting. So all of this combines to create an environment where there are lots of new ways to build applications that make it much easier for developers to get product into customers' hands. Remember, that's our goal, to move quickly, to be able to enable development to build products fast. But at the same time, all of these new application development methodologies also have some risk. And unfortunately, applications are still the most common way in for attackers. Among companies that have suffered external-based breaches that occur as a result of some sort of external attack, web applications are the top way that the attack was carried out. So this could be taking advantage of attacks such as SQL injection, taking advantage of cross-site scripting, taking advantage of failures in data validation. 39% of those external attacks were due to web application flaws. And you can see not far behind software vulnerabilities that are often in open source libraries that attackers are able to take advantage of. 30% of external attacks were due to software vulnerabilities. So even as we are trying to build applications more quickly, trying to get these products out there, we're still seeing that attackers are able to take advantage of any gaps that we have in our application development, in our application security. And all of that speaks to us needing to be paying more attention to application security in order to, one, close the gaps, two, still get these products to market in the time that we need. Luckily, firms are paying attention. And let's take a look at what I mean by that. Next slide, Edward. This is actually the piece of data that makes me most optimistic. We asked Forrester customers, what are your top tactical priorities in the next 12 months? And application security is really high up there. It was the top response. 28% said that improving application security capabilities was one of their top 3 tactical security priorities in the next year. That is fantastic news. That means that organizations are paying attention to the risks and the challenges of application development, of application security, and they're willing to invest in order to make applications more secure. We also see that improving threat intelligence capabilities comes in as a strong second. The ability to proactively identify issues and proactively manage the risk. 25% of respondents said that. So they're investing in threat intelligence. And then also in the top 10, tied back into application security, is that notion of building security in. This is the aspect of meeting development where they are, of enabling them to still do all of the work that they do their development processes, and not run outside of how they work in order to address security issues. It's about building security into their daily lives, into their daily tasks. So those are all great signs that organizations are actually paying attention to some of the risks with respect to application security and are willing to invest in the future. And what we're seeing in terms of that investment is investment in both the human elements of application security and in the technology elements. So let's start by talking about some of the human investments that we're seeing to improve application security and build security in. I have to say, I love talking about developer security champions. This is a practice that we're seeing take off around the industry, and I've spoken to many organizations that have launched a range of different types of developer security champions. Some start small, some are much more mature. But let's first ask, okay, what do we mean by a developer security champion? A developer security champion, very importantly, is a developer first. They are a member of the development team. They're not on the security team. However, they are trained up in some basic application security principles, and they represent security on their local development team. Why do they do that? Well, they're helping to bridge a gap here. They have a good relationship with security because there's somebody on the security team that worked with them, that trained them, that's available to answer questions, that perhaps leads monthly meetings with them and with other champions. So there's a relationship building element there. It also helps scale the security team. As much as it would be great to have the security team involved in every single application development project, we just don't have enough people. So we need to scale out our knowledge and better enable development to address some of the security issues themselves. We're giving them the tools, we're really enabling them and giving them some of their own ownership and responsibility. And that's going to allow development teams to address the security issues closer to the source in the code. It doesn't mean that they have to be the experts in everything. Very often they will come back to the dev team with the more complex and sophisticated issues. But a lot of the low-hanging fruit, basic issues, can be addressed locally. So developer security champions really enable that relationship between security and development. That's on the human side. On the technical side, we're seeing a lot more around developer enablement and integration. You know, I recently completed the Forrester Wave for static application security testing. And we asked organizations, we asked some of the SaaS customer references, what's your top priority? Why are you purchasing a SaaS tool? What is it that you're hoping to accomplish? And yes, some of the answers are what you would expect. We want to find vulnerabilities. We want to protect the company. But 82% of respondents wanted to make sure that they were actually enabling their development teams, that they are helping their developers to build secure code. So enabling development, using these tools to make development work better, work faster, is a huge part of application security tooling these days. You can also see that 79% are really interested in making sure that these are integrated into the CI/CD pipeline. That's where a lot of the automation comes in. What else are we seeing? Next slide. We're seeing a lot of that integration. Regardless of how these are deployed, security tools, whether it's in the cloud, whether it's on-prem, the need to integrate with the developer's environment, with the CI/CD pipeline is becoming more and more important. You can see 44% of the customer references we spoke to are integrating with Jenkins, 35% with Azure DevOps. And the reason that they're doing so is it allows developers to address security in their existing tooling, in their own environment, and not have to leave that environment, go to some other set of tools to address security. They can build it in. And what that means is they can address security issues much earlier in the process, more organically in their development environment, and just more regularly throughout the day. It's the difference between seeing an issue and fixing it now versus being told in 2 or 3 weeks or even a month later that there's an issue you have to fix, and then having to go back into your code, remember what the heck you did, and then try to fix it and relearn a lot of what you had been doing that perhaps you hadn't touched in a while. Finally, what else are we seeing? We're seeing a lot more shifting left. And I know this is an overused term, but what it really means is we're not waiting until testing or deployment or staging to integrate security tooling. We're building it into the development process. We're building it into the build cycle so that developers are able to find flaws much, much earlier in the process, where frankly, it's faster to fix, it's easier to fix. We find that when organizations discover these vulnerabilities earlier, the time to remediate is a lot faster. You get them out of the code sooner. So we're seeing with really all of the tools static application security testing, software composition analysis, interactive application security testing, dynamic application security testing. Organizations are planning to implement all of those much earlier in the life cycle. Yes, it's still being implemented in test phase, but we're seeing an increase in the development phase. So that really speaks to that focus on addressing issues early, helping the developers find and fix bugs as soon as they show up, rather than waiting for some fire drill, a week before deployment when suddenly the security team throws a bunch of new issues. This helps avoid that type of situation. So, what does this all mean for you? Couple of key points. One, we've talked about this integration between security tooling and the CI/CD pipeline. At a higher level, this is really about building security automation throughout the software development lifecycle, including as early as development. By integrating with IDEs, integrating with build tools, and automating those processes so that alerts are more automated, so that fixes are checked regularly, and the right people are informed in a much more automated manner, you're going to see fewer vulnerabilities. You're going to be able to scale your development team, and you're going to help educate your developers. Let's dive into that one for a minute. What we're seeing is that a lot of security tools these days not only provide information on flaws, but they provide training in real time, so that as an error is revealed to a developer, they have the option to click on a link to get some additional guidance, click on a link to get some interactive training, so that they are learning in real time how to build more secure code. It's very different from taking a class in secure development, and then a couple of weeks later, maybe you remember a little bit of what you learned. Nowadays, a lot of the security tools allow real-time, context-specific education so that you can learn as you go. And we all know that learning by doing is incredibly effective. What else is it that you need to look for? When we look at pre-release testing tools, 3 things to consider. You want tools that are really going to embrace that developer persona, that are going to cater to the development needs, that are going to allow them to build secure applications in a faster, more seamless manner. We're also needing tools that go beyond the traditional definitions of code. I talked at the beginning of this webinar about APIs. I mentioned low code. I mentioned open source. We need pre-release testing tools that are cater to the way that developers build applications today. A testing tool that doesn't support APIs isn't going to be particularly helpful if your application is API first. So make sure that the pre-release testing tools are, to some extent, future-proofed. If you think you're going to be getting into a lot more API development, make sure that your testing tools support that. Look for the right set of tooling that's going to allow you to test low-code applications, particularly because a lot of those are built by citizen developers that aren't working within a standard CI/CD pipeline. So you may have to look at low-code testing a little bit differently. And finally, as much as we talk about the need to support the developer, some of this just comes down to we got to be accurate. We've got to be fast. So making sure that the pre-release testing tools, as they are being integrated into the pipeline, as they are supporting the developer, are not generating a lot of false positives, are not holding developers up with long scans or a bunch of results that can be filtered as irrelevant or false positive, that's a huge boon. Combine all of those together to really get the type of pre-release testing tools that you are looking for. So where does that leave us? There are 5 key takeaways I want you to come out from here, and then I know Sujanya has more to say on these areas. First of all, goes back to speed. Dev teams are moving quickly, and they have to. Think about the past year. How many organizations had to suddenly shift to a much more digital experience for their customers who could no longer come into their stores? If you had security saying, whoa, wait, we have to test this and you've got to spend weeks doing some additional work on this before we can deploy it, the business could very well have said, look, we can't afford that. We have to stay open. We have to stay in business. So ultimately, the job of the security team is to enable development teams to meet those business goals. Developer security champions are a great way to help organizations bridge the gap between security and development. It's about going outside the silo, which I know, Sujanya, you're going to be talking a little bit about later. It helps organizations really enhance communications and spread security more broadly throughout the organization. We've seen how new development methodologies are going to help businesses better engage with their customers, offer new lines of business, new lines of revenue, help get products out to market faster. Our job as security professionals is to make sure that we are supporting that, enabling that, and not saying no. Our job is to say, how can we help? How can we enable this? How can we make this project secure? We're seeing organizations embrace security earlier in the software development lifecycle. We're seeing that left shift. And ultimately, our job is to support our development teams by integrating with their preferred tooling so that they can continue to build the applications that they need to build, meet their goals and requirements of getting product out to market quickly, and allow them to do their jobs while we are continuing to do ours. Sujanya, Edward, I know you both have some thoughts on this, so I will turn it over to you now.
Thank you, Sandy. So please feel free to ask your questions in the chat and we will take them later on. We see that companies are embracing digital transformation nowadays. And Sandy mentioned that 41% developers deploy their applications monthly or even more frequently. It's because they want to test their ideas quickly on the market, fail faster, and iteratively improve their application with early feedback from their customers. They want faster time to market. But in order to have faster time to market, it's important to break the silos as well. So if the security team and the DevOps team in your organization is working independently, then it could take a long time to implement even a small change. So security really needs to be a shared responsibility between the different cross-functional departments. We also see that companies want a scalable business model. And not only the business model, but also the underlying architecture needs to be scalable. Let's say, for example, you own an e-commerce website that experiences peaks in web traffic during certain periods of the week. So you need to be able to leverage the cloud and increase your resources during those busy periods and pay only for those services. Then finally, we see that companies want to reduce the build costs. They want to do this by fixing issues early in their life cycle. And in order to benefit from all these elements, companies are moving to a new dynamic called DevSecOps. This is just an expansion of DevOps, something that you're familiar with. And here we shift the emphasis on security to the earlier stages. And the right way to do a DevSecOps model would be to automate everything as much as possible so that you can constantly detect and respond to threats. You can bring a change in your culture, and you need to adopt good security tools. So we know that DevSecOps ensures that you integrate security earlier in your lifecycle, but you also need to make sure that your entire software delivery process is automated. For example, if the developer, every time he creates a code, a source code in your application, a new version should be built, tested in the CI/CD pipeline, and then released and deployed automatically without having to wait for months. So it's really important that all these stages are automated for you to have a successful software factory. Now, microservices, it's quite a buzzword these days. And it seems that companies are adopting the microservices approach to deploy their applications independently. They do not want to contain their applications entirely in a virtual machine anymore. But there are certain things that we need to keep in mind when it comes to microservices security. For example, one approach is not enough anymore. Like Sandy said, a lot of companies have SAST, DAST, and SCA tools in their premises. But while SAST is a powerful tool, it can give rise to a huge number of false positives. Similarly, DAST and SCA will help you spot a lot of vulnerabilities, But at the end of the day, it's overwhelming for a company to handle them all. So you need something that will complement your SAST and DAST approach and help you correct the vulnerabilities identified by these tools. Then we see that it's not just about vulnerabilities that attackers can exploit in your application. Of course, you need to keep into account the OWASP top 10 attacks, but there are some underrated attacks like credential stuffing, for example, which do not target a particular company in general, but any company that has a website with some login credentials could be susceptible to these attacks. Then we see that the API traffic flow or the east-west traffic is increasing due to the usage of microservices. Now, what is east-west traffic? So when data packets are transferred from one of your microservices to another, it is called east-west traffic. And it's really important for you to secure this kind of sideways traffic so that your internal system is not compromised. Then finally, we see that companies have legacy web application firewalls in their premises, which follow a really traditional false positive management process. And according to this, they deploy their application in production and then put the web application firewall in warning mode for 1 to 2 weeks, and then again in blocking mode. And to be honest, this kind of control is no more effective for a secure and the modern software factory. So how to secure your cloud native microservices in this DevSecOps age? In order to counter the pain points that we just discussed, our idea is to provide a cloud native application protection solution called Trusted Application Factory. This solution has our security engines built on 20 years of expertise, running in a container close to the application code. This way, the security is always up to date and aligned with the application version. It scales really easily with the application traffic, and with early detection in a pre-production environment, it will reduce your false positive rate in the production phase. It will also ensure that your performance and availability is high, and all this while maintaining your speed to market. So Edward will tell you more about its underlying concept.
Thank you. We can see that there is really two pillars in Trusted Application Factory. So the first one is adapted to next generation application or adapted to cloud native application. So the main idea is that this product Trusted Application Factory is meant for this new environment to protect microservices, leveraging containers, for example, that need to really scale easily, both the application and the security solution associated to it. So this was the first pillar. The second one is designed for DevSecOps. So the second one is we will integrate into the DevSecOps tools like the CI/CD pipeline, leveraging the same configuration file formats like YAML file and so on. And depending on the maturity of the customer, some of them will choose Trusted Application Factory for the left part to have a security solution with the same technologies and the same maturities and the same security solution and application maturity. And the second one, if they enter to DevSecOps strategies, be able to have the good products in order to sync the security at the build process. So in this whole environment, we integrate into DevSecOps universe. So what we do in the code and build process is that the developer is being able to write a YAML configuration file in order to tell which application will be protected, in order to say some information about the context of the application in order to have a better protection, to have security engines tailored to the context of the application. They could provide us, for example, Open API file so that we could do a positive security approach, and each thing that is allowed by the Open API will let it pass, but each other thing we will directly block the traffic. And the workflow has code ability. So the idea between behind workflow as code is to be able to write some code in order to describe the security as if you would have write some code for your application. So this is the security as code here. With the DevOps, we spoke about infrastructure as code. Here we can do security as code and to describe the security in configuration file in order to automate everything. So this was for the code and builds. After it, in the test phase, so we will integrate Trusted Application Factory directly into the CI/CD pipeline, so that if, for example, you test some vulnerabilities with a DAS software, vulnerability assessment software, you are being able to see the real number of vulnerabilities of one application. And then with Trusted Application Factory, the number of vulnerabilities that are proactively blocked by our solution. And then you know your remaining risks that you need to address, for example, with some custom rules inside our security solution. But the security is not only the only thing interesting inside the test phase. For the false positive management, so the idea is that we will, with some real traffic, we will detect some possible false positive, and you will see it in the demonstration part. We will give some hint in order to correct them for a developer, an ops, or a security champion. Then, just before the release, we will transform each thing that the developers, ops, security guys will give you through configuration files. We will compute them and be able to inject them inside our security container once it will be put in production. So for deploying, we will deploy in the same kind of environment than the cloud native application. Let's say, for example, a Kubernetes infrastructure, and we will scale directly the same way the app will scale and so on. So we are being able to really put this security solution close to the application. And then we deploy the configuration associated. We directly inject them inside the container. And once it's running, we will directly block all the attack in the run phase, like your classical web application firewall. But we will really leverage all the information that the developers or the security guys gave us inside the code and build phase. And then we will monitor then the health of our container to make sure the security solution is up and running. And each time we will detect something or see an interesting information, we will be able to produce some logs to export them and so on. And it will be useful for you to analyze the security events, but also all relevant events that could help you for an investigation, for example. So, which is also interesting is that we can use the products in two different ways. Let's say I have a WordPress application inside my company. For example, one module, one plugin of WordPress has a vulnerability. Maybe I will ask my DevSecOps team to directly do something to block this vulnerability. So it's really these teams that handle the applications that will take care of the security. But maybe I have other WordPress application inside my company, let's say 200 WordPress applications. And if a big vulnerability occurs on WordPress and could affect all my WordPress application, a transversal security team, even if it's not really in the DevSecOps spirit, could also take care of it centrally. So you could imagine the two models, the traditional one where we centrally deploy some information about the security, and the specific one that is more tailored for DevSecOps strategies. So since companies are moving to DevSecOps, there are some different teams collaborating and so on. It's really important to be able to provide security the two ways. Yeah, we have some generic security engines, like Sujanya said. We put them inside a container. So one example of a generic security engine is about operating system injection. So the problem is that when you have some user data as an input and you trust it without any verification, maybe they put some things that will allow them to execute some arbitrary command on your servers and backends, and it could be a huge issue. So here in this example, I leverage in my PHP code a function called system in order to ask the operating system to do something for me, and I will put who is, then the user input. So if the user input is google.fr.com, for example, it's okay, it will work. But the malicious guy could use some escaping characters and then some comments and then install a backdoor or exfiltrate data and so on. So we will both detect escaping commands. We will see that the ls is a Unix command, and by correlating these two information, we will be able to say, okay, we will proactively block this vulnerability exploitation. So it was just one example, but just to give you an idea, with the generic security engines, you are protected from the OWASP top 10s attack. Then, for example, if I have an API to protect, so I'm an API developer, I will create an open API file because as a developer, I need it in order to do communications with a public API, or in this example, through microservices that will connect to each other. So since we as developers, we already produce this kind of file, which is interesting is to leverage them in order to do better security and to have more context. So the idea is that we will inject this open API file directly through the CI/CD pipeline to Trusted Application Factory, and we will enforce them. So then if some traffic will come to the API, we will make sure it's okay with the Open API convention that has been written. If it's okay, it's allowed. If it's not, it's denied. But we have also, like I said, our generic security engines that will detect some vulnerability exploitation attempt and allow you to investigate on top of this. So mixing a positive security level, which is more easy to do on APIs than on classical website, and leveraging our generic security engines, allow you to really easily have a strong security strategy, both on your north-south traffic, but also east-west, like Sujanya said earlier in the presentation. So with the same approach, you will be able to protect what you used to protect with traditional approach, but also all the communication between your microservices. So I will speak a little bit more about the architecture of the product and show you a demonstration. So here we put an example of Trusted Application Factory deployment inside a Kubernetes cluster. Directly integrated, for example, inline in some pod. So it will act as a reverse proxy and be before the application. And if the traffic is not allowed, it will not go through the backend. Then you have another way to do it is as a sidecar container. So the idea is that it's quite the same, but we are closer to the application, and each time the application will be deployed or scale somewhere, we will follow this application. But yeah, the idea behind is the same. And in the example, we put a Kubernetes cluster, but you could deploy it with a Docker Swarm. You could deploy it in the managed instances of Kubernetes in Amazon, Azure, Microsoft, and so on. So I will show you a small video about it. So here I'm directly in GitLab. So I have different configuration file like GitLab CI, so the configuration of my CI. So I have an API to protect, an example of API. Then I will launch my web application firewall. I will configure it. I will inject some YAML file in order to the container have the good configuration to apply for this application. Then I will run the API, do some tests on top of it. And after the test, I will ask Trusted Application Factory if there are some false positive to give me some hints about it in order to easily correct them. So this was the CI YAML file. Then I have the YAML file about the main configuration of Trusted Application Factory, telling him what backend he will protect and so on. My YAML file for my exception handling, that will be a written file here with one example, and the test that I will do. In the last tests, we made something in order to do a false positive in order to show you. So I will put HTML inside a variable. And so we will fail because this test will fail. So the build will fail. So if I want to have more information about it, I will look at my log. So everything is running, my API, Trusted Application Factory. The first tests are okay, and I see that the test is failing. So I did that the return code that I was waiting, and since I asked to Trusted Application Factory some hint about it, it will give me the good configuration in order to say, okay, it's a false positive. I will directly put it inside my exception YAML file. I copy paste it, I will apply, and then if I redo the same process, everything will be all right, and the test is running. Then if I do, so it was one example of Trusted Application Factory inside a CI pipeline. So here, just to show you the same kind of environment, but with Kubernetes. So here I have directly some configuration of my APIs, deployment, and so on. And you will see my CI file with directly the Kubernetes command in order to deploy the same kind of environment with the same kind of use cases. And here it's leveraging Kubernetes on top of GCP platform. So here it is.
Thank you, Edward. Now, let us look at some of the key messages from the information that we presented today. We saw that in order to leverage the benefits of a true DevSecOps model, 3 things are critical. Firstly, automation. Secondly, cultural change. And thirdly, good security tools that will help you achieve the first 2 elements. We also saw the value of integrating security early on in your pipeline in order to achieve high quality and secure applications. Because remember that if your CI/CD pipeline is not secure and automated enough, then your applications will not be able to deliver their full capabilities. We also introduced you to Trusted Application Factory, which provides cloud-native security for your cloud-native applications. Now, this solution is completely automated, right from the development code commit to the production phase, and it integrates easily in your DevOps universe, like Edward mentioned before. So developers don't have to learn some new tools, languages, or concepts because it uses commonly used formats already known to the DevOps teams. And it integrates easily with other tools like GitLab, Jenkins, etc. Also, this solution, along with an open API file and our proactive security engines, integrates close to your application code in your existing Kubernetes or Openshift environment in order to improve the overall security of your microservices and to reduce the false positive rate during production. And finally, we saw that this solution links the different cross-functional teams in your organization. And it also helps in building collaboration and removing the different silos. So we have a set of solutions based on a central web application firewall technology that we have enhanced since the past 10 years. So this web application firewall could be deployed on premises in a virtual machine or a hardware appliance to protect your mission critical applications. It could be deployed in a cloud marketplace like AWS, Azure, or Google Cloud Platform in order to reduce your upfront investment and promote easy scaling. We also have a software as a service solution called Cloud Protector, which is really easy to implement and configure. You just have to redirect your application traffic to our infrastructure, and within minutes, you will be protected. And finally, we have Trusted Application Factory, which is our latest offering or solution. And it uses containerized technology to protect your microservices. You can test this freemium version on our DevSecOps community website. Speaking of which, I'm really pleased to introduce you to our DevSecOps community, which we built for API developers and cloud and security experts, such as yourselves. On this platform, we share trends around different application security subjects like security as code era, the different application security testing tools market, CI/CD pipeline, etc. And you can exchange with your peers on this platform. You can share your best practices. And if you face any issues around secure application development, you can always reach out to our experts. So I'm sure you will love this community, and we welcome you to join the community and really look forward to your participation. So if you have any questions.
Yeah, so we have one question about, you speak about top 10 OWASP vulnerability, but what can you do against, for example, credential stuffing? So yeah, for credential stuffing, it's a mix between, for example, so again, the aims of credential stuffing is to take, for example, on the dark web, a huge list of login and password, and then to test them against your applications. So it's not a vulnerability exploitation. But with a web application firewall, you will be able to put some rate limiting, for example, to limit the number of requests that an AP could be done. But the people will leverage some botnet in order to do it. So we will also use some capabilities like bot mitigation to make the difference between a human and a good bot, but also threat intelligence. Since people will rely on botnets in order to have a lot of IPs, we will look at the reputation of the IP. So we have some feeds of threat intelligence directly integrated inside our product. So it's a mix between several engines that will be a strong strategy against attack like credential stuffing, for example. We have another question about the pricing model. Do you want to answer? Do you want me to answer? As you
yes, go
yeah.
on.
So the pricing model is for Trusted Application Factory. It's some pay-as-you-go model. So you will pay for what you use, and it will depend on the number of applications or API that you will protect, but also the volume, the number of requests on top of it. And since some customers do not have do not want to do in a full pay-as-you-go model and want to be able to pay before, we have a model so that you can get some credits in the application and then consume them in a year. Another question is, how do you find developers security champions? So maybe it's more for you, this question, Sandy.
Yeah, thank you, Edward. It's a really good question because you know you don't just want to point to somebody on the development team and say, "Congratulations, you're the security champion." And I have spoken to end users where perhaps it started that way, where perhaps the development manager just found somebody on the team who happened to have some spare cycles and said, "Congratulations, you're going to be our security champion." And then that identified champion would show up to the first session, not really know what was going on, and as they learn more, maybe not be as engaged. Ideally, you want to find developer security champions that self-select, that are interested in security and find something interesting and raise their hand. And I've heard of a bunch of different ways of doing this, but one of my favorites is a story from a CISO who told me that what he did is he hosted a lunch and learn for the development team. And he rolled back the patches on the applications that the developers had built and showed those developers how they could have exploited vulnerabilities that were in the now, rolled back patches, so, unpatched applications. And a couple of developers found this really interesting and exciting and got really into it. And so that was an indication to the CISO that they were good candidates for security champions because they got excited about finding and exploiting these vulnerabilities.
I have another question for you, Sandy. What are some examples of automation that can improve the developer security experience?
One of my favorites is around stage gates in the build tools. You mentioned a little bit about Jenkins integration in your presentation, and I think I mentioned it briefly during mine. But what if during the build phase, you are scanning the application and based on the number of vulnerabilities and security flaws, or reintroduced security flaws, or flaws that had been in there for a certain period of time, the build would fail based on those definitions. So there's an automation that can go into that to sort of, guide in when should the build fail, when should it not, and allow you to automate and get more information so that it's not always failing just based on any number of vulnerabilities, but based on, say, particular critical vulnerabilities or long-lasting ones or reintroduced. That's one of my favorite aspects of automation. The other one that I like, and I mentioned a little bit, was around IDE integration and having more automated guidance for the developers when they introduce a security flaw as they are coding, to have the IDE be able to, in real time, in many cases, identify that and display guidance that helps them find and fix it in real time rather than later.
Okay, perfect. Thank you. I would like to thank everybody that came to this webinar. Just to let you know, the recording will be sent in the next hours, so that you could see the webinar and share it to your colleagues, for example. And I would like to say a special thanks to both Sandy and Sujanya, because it's my first webinar for both the three of us. Really thank you, Sandy, and the whole Forrester company for doing this with us. And thank you, Sujanya, for this first webinar with us.
Thanks for having me.
Thank you. Thank you all, and see you soon.